Hello everybody. My idea today is to talk about business intelligence, but the idea is to tell what a developer do in business intelligence. Actually, in my experience, a lot of people doesn't really have knowledge about business intelligence, and it's a lot of people related with reports, and actually reports, it's a part, but it's a little part in the front end. We do a lot of things behind, and I think as a developer it's quite important at least to have a basic knowledge in BI, because maybe tomorrow if you have an application and they ask you to do a feature that already exists in BI, you shouldn't try to invent the wheel 2 times. You can use the BI system. This is my idea. Is working this? No? Oh, whatever. My name is Wille Esteche. I'm developer, mostly .NET developer. I work with BI. A lot of tasks was with BI too. I'm from Knowit development in Stockholm, and I work for Carnegie Bank. Right now I'm working on the back end and architecture, infrastructure, and right now I actually helping in front end. We are almost done in the back end, so we are working mostly with front end. With BI I've been working in TDC, like 30% of my time there. I've been working with cargo. The last task was in Nobina, 2008, maybe half year sitting there. My idea to try to explain what is BI is I was thinking to create a story, a little bit my story, a little bit the BI story, IT story. I'm going to invent a lot of things. I think it's a good way maybe to explain what it's about. Then, if we go back to the early 80s, then the companies started to do a big investments in computers. And the question is why they were doing this kind of investment in computers in the 80s, when maybe they want to register an order manually and another order in a computer. Actually, they didn't have a personal computer, have terminals and connecting a network and sending the data to a database. That it was a big data, not really big data, it was a big computer actually. Yeah, we don't talk about big data, 80s. Anyway, there was a lot of good functionality, but one of the biggest reasons is that if they register everything in a database, in a computer, when they want to count how much they sold, how much they bought, or try to get statistics of the data, they can do a query and they get it back in seconds. Before they have to, one person have to count hours, and 3 others need to verify. It's happening in 60s, 50s, 40s, always, mostly in business too. And of course it was saving a lot of time, so it was a very good idea to put money in computers. But with the time, if we go in to maybe to the 90s, then the databases start to grow, and a lot of people, everybody want to. Now we're talking about we are having personal computers. A lot of companies since I don't know, maybe a newspaper say I want to have all my articles since 1850 in a database, and the database grow, and the queries doesn't take seconds. Now they take maybe hours. And do you think it's a problem? A big problem we have in 90s. Today we still have this problem, but it's that the system was down. There was a lot of reasons. Maybe network, maybe hardware, but one of the biggest reasons actually was the databases. And I'm going to try to explain why. If you think about a database in this time, if you have one CPU or maybe 4 bits or maybe 8 bits, it means that we have maybe 4 parallel processes or 8 parallel processes. We don't use so much parallelism during this time, and that means that maybe one process was reserved for the operating system, and maybe a database got 4 results to run parallel. I mean, if you think about this situation, if we have a database, and suddenly if we put a scenario that the database has 4 resources, and we think about that maybe the CEO come in and say, I would like to have 20 years transaction data because I need, I don't know, I need to plan for the next budget, the next month, run a query running 1 hour, come in a boss, and I would like to see how my employees report for maybe 20 years ago because I need to, I don't know, plan vacation or something like that. 2 hours running, coming another, data analysis, we have something wrong with data, I need all the transactions, 3 hours query running. Then come the first person, I don't know, business control, and say I need to see, compare the data from this year to this year, give me 30 years transactions data. And what's happened now? Everything is busy. Nobody can work right now. Then I know myself, everyone that run small queries and applications that only want to access an order, only want to create a buying order or a selling order, everything is timeout. Why? Because they have to wait at one of these processes and then can get in again. And this is a big problem. And we have to find a solution. Of course, if we cannot sell, and it actually was quite common that you call a company and say, I want to buy something. I say, no, sorry, the system is down, can you call later? Then one day, or maybe one day, a technical person think, okay, I have a solution, but I need to talk to the CEO. And then I make a question, I say, I have an idea, but do you think it's possible, you get 20 years transaction data, but up to yesterday. We don't care in today's data. Up to, it means all the history, 20 years, but up to yesterday. You don't have today's data. And you say, yeah, actually we barely use real-time data for this kind of plans. Two works, then let's go. The solution should be something like that. During the night, when nobody works, when everybody's sleeping and maybe 2-3 persons working, then we make a copy to another server in another database. Then the next day, everybody that running application with small queries can still work with the application database, and the people that run big queries run to this one, to the copy one. Of course, you don't have today's data because the copy was from yesterday night, But in this case, they can still work. They can work, and they can kill each other's. And was it because of course there are no 4 persons, there are much more persons searching data. And this is quite good actually, and it was a good solution. Then the CEO come back. And the other day say, actually we have more programs than only this program. We have maybe an ERP system, we have big accounting book, and we have, I don't know, maybe we have a product system to storage all the products, or a CRM system for the customers. Then there's no problem. We can do exactly the same for all the applications. Then we do copies. All the applications have the database, and during the night we do copies to another server, and we do exactly copies of the database. And then you can create your reports to your database, each program, and very good. And actually the CEO is very happy, so this is very good. But there is a problem. This is the same company. The application, the programs actually, we are repeating the data. We have the same countries in all the programs, and we have the same products, we have the same customers. So I would like to have maybe, because in this case I have 3 different reports with different connection strings too, and it's very difficult to get a build of everything. And the technical person maybe think about a little bit and say, we can do something like that. We create a very big database, and instead of copy database, now what we are doing is to copy to our tables in the same database. And we can put the names maybe with the source to identify where they're coming from. But the idea is now that the CEO can use only one report and go exactly and go only one and go only one database. And actually we need to transform the data a little bit. Think about that maybe one application is in English, the other is in Swedish or Norwegian, and we need to translate it because to have the same report, actually we want to have the same language. Maybe data format application is coming from the United States and they have another date format. maybe another is from China and has completely different student. We need to make everything suit the same data type. Then it's possible to get a report for everything. And actually, you see, I think this is a very good solution. Actually, it's a very good solution because now can create one report, maybe analyze the data from only one source and get the bill from all the company. This is very good. Then I'm going to put a name to this big database that actually is going to be a giant database. We used to talk about that this is a data warehouse. Maybe you hear this word before. It's quite common. We talk about BI data warehouse, and we used to point to a did that with you. Another term here, another word we have in BI. We talk about application database. Why we call this application database? Because this is a database too. But here you can run big queries, 1 hour, 2 hours, 3 hours. In the application database, we don't want to run big queries. 1 minute max. I should say more than 30 seconds is still bad. And if actually more than 5 seconds running a query here, you should consider to make some changes. There should be small queries here. And here you can run big queries and do whatever you want. But it still is a copy. Actually, I can tell you that the real name for this kind of application database in BI is not application database, it's source. And you wonder why? It's because it doesn't need to be a database. It can be JSON files, application that's all JSON files, or maybe flat files, text files, or maybe it's a phone system sending recitation of how much minute code is to this place, or a camera system, I don't know, maybe registering people get inside. What we need to do is to put inside in the same database, everything has to be in a database format and have to merge that. We can still create one report of this. Then this is basic how a database look like. Is this much more things. The integration here in the middle, talk about at night, has a name too. This is ETL, and what it means that extract, transform, load, and it's extract because we extract the data from the source. We transform the data. I just tell about what we transform and why, and we load in the data warehouse. ETL is a very common word in BI. And then we have something like that. I should say end of 90s, maybe beginning of 2002. People at the office, maybe when they're going to leave the office, they run a process to create a report. They go home, and they come back to the next day, and maybe it's not done yet. And this was very common actually, because the data warehouse now is giant. If you think the queries go slowly because we don't have millions rows, we have billions rows here, then think about that, how it's going to be now. We have a big problem actually. Of course, the rest of the company can work, but they need data too. It's quite important. They need to make decisions a lot of times. They need to analyze what we are doing. Then one day, this technical person saying, okay, I'm going to take a look in the tables and see what we can do. If there's something we can do here, and if we take a look, maybe an accounting book. If we say this is a transaction table with million rows, I take only 4 rows. And what can we do here? Everybody knows that text in IT is mean very big data type. Numbers are nice, but can we some way maybe translate Norway to the number 1, Sweden to number 2, and maybe Finland to 3, and Denmark or something like that? Like in this way, then actually this table is going to reduce a lot. And actually it's true. This table is reducing a lot when we remove away all the text from this table, and then we create also a translation here because we need to know what 1 means and what 2 means. And actually it's a very good solution. Then what we do, then if it's a good solution, then let's do it for everything. For the cities, for the product, for the customers. And then we have, and then it becomes something like that, like the transaction table here, we don't have text. Actually, we say text is forbidden. Only numbers, maybe dates too. Sometimes weird, but depending on the policy. But we don't want to have text. And actually, this has a name too. The name here is a fact table. Here we have the measures, and we have a lot of keys. And the fact table is connected to this. They are not actually translation tables. They have a names too. They have dimensions. They are dimensions table. Actually, it's a dimension because you say, I want to search what, I don't know, what Pelle bought. And I don't search here by Pelle, I search by the number 2. And I get everything here. And for a person that can make an analyzing the data, they see the names, but they don't see the keys. That because become a dimension. It's going to be something like that. They can start fact in the middle and dimensions around. Sometimes some BI system we call this data mart, not always, depending. And right now we have a better system. As you say that now that maybe instead of 9 hours to take 1 hour to take a report or to run a process to create a report, 30 minutes is much better, but as you say, it's still not so good. If, I don't know, a boss wants to know how much the employees report and have to wait half hour for getting results, then we need to work harder. Then this technical person saying, okay, right now I'm going to sit down with the business controllers. I want to see what you do with the data, how you work with the data. And the business controller is playing, yeah, I can tell you. I get inside the database and I analyze data. Then I extract 20 years data transactions. Then I aggregate all the data by years and see the totals. Actually take time to extract and take time to aggregate and then see the totals. The total how much we bought, how much we sell. And then, I see maybe 2013 is something weird, this number, this is 1 million more. I want to get in 2013, and then I get inside to maybe quarters, and then I see, okay, 2013 quarter 3 maybe looks weird. Oh, this total does some. I want to get in the months too, and I say, oh, maybe September is not so good. I think I know what is the problem. Maybe this business area, and in the end, the technical person say, wait a minute. I sending to you 20 years transactions data, and you only care about one row, 1 year, 1 date, 1 month. This is not working. And I say, I have a solution. And actually, the first solution this person thinks should be good is to during the night when they have the ETL system, when we do the integrations, we are going to prepare a table with only totals. And we are going to do exactly like that. By years, sales, both. Actually, this is a history. 2018, 17, 16 is a history. Maybe the current year I can update every night, but the rest I don't need to update. Then the next time, the business controller wants to run the report, it's going to take milliseconds because this is a very small table. It's a good solution, but the business controller says, wait a minute, I want by quarters too. I want to drill down in there. No problem. Then we create another one. Years, quarters, and then we can make a relation to. In 2 seconds, you get the next level, no problem. Okay, but let's do it for all the dimensions. Continue in this way for all the dimensions we have. And as you say, like, a business controller want to not see one dimension, want to even cross the dimension. They say it should be good. The best should be to cross all the dimensions and to have totals for each combination. There's no problem. If you think about we have 30 dimensions, so we're going to cross all the dimensions. We are going to create maybe more than 900 tables with this. A database with 900 tables with the pre-totals is going to be crazy. Impossible to maintain. Think about if you want to, they come and say, oh no, we don't want to have quarters no more. How many tables do we need to change? This is not working, I say. And actually the big companies like Microsoft, IBM, they've been thinking about it, and actually there's a logic behind, you know. All dimension crossing, preserving totals, to be able to make a tool to, you select the dimension, you select what's it, the metrics from the fact table, and the tool can do it for you automatically. And actually, I work with Microsoft, and Microsoft creates something called Kpis. And the cube is exactly that. You get inside, Microsoft has a tool that the name is Analysis Services, and you select these dimensions, and I want to have the data for these measures or metrics, and then start to generate, and you get a cube. And it's going to be then something like that. This is an example actually, but you can put a lot of dimensions and a lot of fact data. I would like to show you how it works actually. I download a sample code, a sample cube actually. That was wrong. Right here. Oh, I need to cancel. Oh, so sad. I'm in Excel now. I can show you that here you see you can go get data from the database, and you have analysis services. Analysis services mean a cube. You see the symbol? There is a cube. I already connect the cube by download, and to the right, when I click here, this is for the pivot table for the cube, and you see to the right here we have metrics coming from a fact table. I don't know, maybe I would like to see, what can I see? Sales, internet sales amounts, the number coming directly. The product total cost, maybe, very fast. A little bit more, I would like to show, if we scroll down, we have something like that. KPIs, I don't seem to talk about, but this is here, there are dimensions. Here we can see accounts, we can see customers. Okay, I want to have maybe, I would like to see what is the country for the customer. Very fast. Now we have, now we can analyze data in milliseconds. This is very fast, it's quite good. Think about maybe you want to add cities maybe, or you want to remove. Even if you want to create a graph, you can do it in seconds too. You don't need to use Excel. You know, there's a lot of system that works with cubes. If I make a chart, I would like to move it to an because I see this was small. Yeah, I'm right. Time should be good to have. Maybe if we take a look in a calendar, I would like to see year maybe. This is very fast. This is very good. Here it's possible for data analysis, or for a business controller, or for a CEO or somebody to get in and see the data. How much we sell maybe. 2013 was a very good year. Maybe in the United States and in Australia was 2, something like that. Then this is what a cube is. Actually, I can tell you, today we are not developing cubes in the cloud. In the cloud we are using Tabular, another system. I choose cube today because I think it's easy to explain what it's about. And this is what we do. When I work in BI, I work in that we say backend, and this is what I deliver. Sometimes we have people that work in frontend in BI, and they create reports or data analysis. Or sometimes, no. If somebody working in the finance sections, they get inside, they access the cube and do whatever they want. They make their own reports. Let me tell you about the tools we use. I can go back here. Oh. I work in Microsoft. I'm going to talk about other products. Microsoft for the ETL, for extracting data from the source and creating the data warehouse, we use integration services. Mostly actually SQL in a way, but the tool is integration services, and it's quite integrated to SQL too, and sometimes we need to code in C# too. For the cube or tabular, we have analysis services, is the tool we use. And for the front end, The front end in BI can be report, data analysis systems. They can be AI, because artificial intelligence, they like to have clean data. And if we talk about clean data, when they say clean data, it means we want to have data from a BI system, because it's already modeled. Microsoft has a report system, a report tool that is called Reporting Services. I don't recommend it. It's mostly for static reports. There are other products, much better products. Other companies are much better products. Something good Microsoft has. The last year they created something called Power BI, and this is I think it's one of the best tools they did for BI. And it's like you can create more than one report and make a dashboard and interact the reports between each other. It's a very good tool. If we have time, I'm going to show a small video about that. It's this Power BI, this is the symbol. If I talk about other products that are not Microsoft, actually I should say SaaS Institute, I think they are the biggest, in my opinion, they are the biggest companies at BI. They have a lot of products. In Sweden mostly they have, I know I've been working for anti-money laundering, all Forex and Western Union using SaaS. The licenses are quite expensive, but the tools they have are very good, both for data warehouse and for reporting. ClickView, the point they had before, that they saved the data in the memory, and it was very fast. But they want you to have a table that is not so wide, but very long table. That, in the end, before was quite common in researchers or universities, because maybe you want to see how a plant is growing and you register every day, and then ClickView was very good for this kind of data. Today is, I don't know if it's a good point, because the technology for the hard disk, SSD, solid state, are quite close to the memory, and they're working very fast too. But today become more like a tool, like a SaaS almost. And IBM we need to talk about, because they are the creator of business intelligence. Very early, 1957, 58, one engineer from IBM created the first business intelligence system. Have nothing to do with the things we have today. Anyway, they have a lot of products. They have big sortiments. But the most famous product they have is Cognos. I don't think it's a good work. It's a good tool, sorry. It's by web application. They give a lot of powers to the users and to the developers, and make it a lot of times slower. And the end user is always nagging that it becomes very slow. It's depending. Sometimes works, sometimes not. Anyway, the last thing I would like to introduce is Power BI, and why I think it's a good tool for Microsoft. And I guess like that, you can create a data set, or maybe two data sets, and from the data set you can create more than one report, 7, 8 reports, and then you create a dashboard, and you put all the reports in different ways, like that. You have the different reports in one dashboard, and then you can make interactions between the reports. You can, if you see this case, this person is using a dimension here, and click here and affect these people and the other one. Right away, it's very good to make analysis and to analyze the data. And then, I think actually I've never been working. I use it to test my cubes and my tabulars, but I see the other developers, and they usually are quite very satisfied with this product. They have a bad side, that is this only works for Office 365. There is a way to take it out, but it's not a nice way. Then you need to have Office 365 in your company, and then pay extra for Power BI. That's all. My idea with that is that tomorrow, when if we are working in a project and the product owner come, I will let you have a new features, maybe a graph about the orders in the database, or the logs, how they look. You say, wait a minute, we don't want to have big queries in our application database. We should send our data to a BI system, And then we can call from the same application, we can call a cube, a tabular, no problem. But this is the way to do it. Do not try to create a BA system in an application because it can easily become a big problem, mostly because if you're going to run big queries, then you're going to stop all the other users in the same system. Then I hope you learned something. Thank you very much. I don't know if we have time for questions. If we have, maybe. 4:22. I don't know. I think I'm over. Yes, I'm over.
Yeah, you're over. But there's only open space after, so I don't think it's too important.
Okay. If somebody wants to get up and drink a coffee, can do it. But, yeah.
Power BI, is that integrated into Excel?
No. It's a separate product completely. In base, they use now all the Office product. They use the same data for the database. For the data connection that we call data model, and actually it's exactly the same. The base is tabular. I didn't explain today. It's another way. And tabular we use in the cloud, and we can easily connect it to big data too. But no, it's two different things. It's two different things. Actually, from Excel, you should connect to a cube, to a tabular directly, and not to a Power BI. Power BI is another tool completely different. As a user, you can get it as a report, as a web report, as an app. It's an app to Power BI, and as a developer, it's a tool. It's a tool completely different. That's all.